Hi everyone, welcome to the sixth lesson for topic 4.1 time series analysis. So this will be our last lesson for this topic as well. So Thursday will be a break, then after that next Tuesday we are going to have a live class which will do a simulation or like a mock exam for your semester 1 exams. Then from there hopefully we can do some revision and score better in your coming exams. Alright, so please refer to the study plan that I have put in the announcement previously. Alright, so let's look at today's learning outcome. So today's we are going to continue to look at how to analyze time series data. So two learning outcome today. So the first one is after we try to model the long-term trends, no matter you are using deseasonalisation or moving average, and we are going to fit in the linear model, which is to fit the least square line to the data. So it's the similar thing like what we have done in bivariate data analysis. Okay, so the second thing after we fit the linear line, then what are we going to do with the linear regression line is to try to do the prediction. Alright, so but there's going to be something different when you try to predict it, which we need to make the seasonal adjustment for the periodic data. Okay, so later we are going to talk about the process, but basically remember that after today's lesson, then you will be able to make prediction out of the analysis of the time series data that you have. Alright, so let's look at today's lesson. Alright, so you should be quite familiar with this table here because we almost talk about this we talk about this in almost every classes that we have. Okay, so finally we are in the last stage today. So let's go through everything that we have done so far. So we know that in time series data, so the raw data that we are dealing with is slightly different or is slightly special when we try to compare to bivariate data because that the data that we are having are basically seasonal data. Alright, so that's like our main focus of the topic. So even all the analysis that we try to do after that is based on the nature of the data, which is having a seasonal variation. Okay, so after that, we know that because it's a seasonal data, so that's why we can't actually we can't actually identify the long-term trend that easy when we try to compare to the data that without any seasonal effect. So that's why what we are trying to do here is to actually find out what is the underlying trend of the seasonal data that we are having. So how can we do that is by smoothing the data to remove the seasonal effect that we have. So basically two approach that we have tried so far. So the first one is by using moving average. So you know that no matter you are doing a odd point moving average or we are talking about centered moving average, so those are different ways for you to deal with different data with different number of data points, either that's odd or even. So make sure that you are familiar with the shortcut formula that we use in the even point moving average as well. Alright, because in the exams you are not going to have like two table, then it will be quite difficult for you if you doesn't know the shortcut formula. Okay, then the second thing is what we just completed in the last lesson, which we talk about deseasonalisation. So the difference between these two is that moving average basically is to find out the average of that particular point and the neighbor points. Okay, but for deseasonalisation is that we try to use a much more systematic way to find out what is we try to quantify what is the seasonal effect on the data, which is what we call as seasonal index. Then after that, we try to remove it by dividing the seasonal index that we have. Alright, so that's basically what we have covered so far. So by using this data that we are having, so today we are going to look at how do we do prediction. Alright, so for the part for underlying trend, so after we have find out the data without any seasonal effect, what we are going to do is to do a linear regression. Then after that, put into the part where we try to do prediction. So we'll come to this part again. So let's try to go through the notes part first. Then after that, I'll come back and try to explain it again. Alright, so after we smooth out the seasonal data, the long-term trend or the trend can be seen clearly without any seasonal effect. So we are able to actually identify whether there will be a long-term increase or long-term decrease. So if let's say you cannot see a trend whether it's increasing or decreasing, it's just like fixed, right? Then we doesn't really need to find out what's the trend, because you can imagine the idea where if there's no increase, no decrease, then which means that in future the prediction will be kind of the same as well. So if let's say it's the same, then we doesn't really need to do like analysis then after that to find the prediction, right? Yeah, but that's basically the thing that we want to do, because uh we want to forecast what is going to happen in a near future. Then from what we have, then we try to see whether it's increasing and decreasing, then that's going to tell you the value that's going to happen in the future. Okay, so if the smooth data follows a straight line pattern in general, so normally the question that you'll be having, they are able to satisfy this idea lah, because if not, then you can't continue with the prediction, because linear regression model is the only statistical model that we have learned under this topic to solve statistical problem. All right, so I mean, in the real life situation, you'll have you will have a lot more statistical model, but it's just that in our syllabus we only learn linear regression. So that's why the question that will be given are mostly in this case, except that we are talking like bivariate, which you can use like residual plot to access whether linear model is appropriate or not. Okay, so yeah, in time series, normally we are dealing with, after you carry out moving average or deseasonalisation, then normally we are trying to use linear regression to fit lah. Okay, so if the smooth data follows a straight line pattern in general, then we can fit a linear regression model to the data. So after we feed the data into the model, then which means we'll be able to get an equation of the regression line, right? Then we are going to use it to do our prediction. Okay, so something you can see is based on the previous table, right? We know that what we have done previously is find out the moving average, the data after we have carried out the moving average, or the data after we have carried out the deseasonalization. So which means when we try to fit in the linear regression model, the data that we are using, right, are basically the data without any seasonal effect. It's the data that after we smooth it. Alright, so which means that the seasonality of the data has been factored out when we try to do this. So which means that what is going to happen is that after we find out the prediction by using the regression line, to make the predictions become much more meaningful, this result must be seasonalized again by multiplying it with the respective seasonal indices that we have based on the season that we are trying to do prediction. Okay, it seems like a bit complex, but yeah, no worries. Later when you try to look at the example, then you understand it. All right, so we need to seasonalize it again so that it is in keeping with the raw data that we have. Okay, so later we'll be using two examples. Then from there, hopefully you can try to understand why is this whole thing works. Okay, so from the previous lesson, we know that when we try to deseasonalize the data, what is the formula that we are using? So you can look at the word deseasonalize the data, which means that you are trying to remove the seasonality from the data, right? So that's why it's called as deseasonalization. So when we try to remove the seasonal index, what we are trying to do is we are using our raw data, and then we divide it by using the respective seasonal index. So this is to factor out the seasonal data. To factor out the seasonal effect. So which means that we try to remove the seasonal effect from the data. This is index. Alright, so we use the raw data to divide by the seasonal index. Okay, so when we try to talk about this part is we want to, after we find out the prediction from the data that we have smoothed, so from there we want to factor in the to factor in the seasonal effect again. So which means to find the seasonalized data, or you can say it's like seasonalized prediction. So yeah, to seasonalize the data again, so we are going to do an opposite operation, which is to multiply the data that we have. That's not raw data, I'm just going to use data lah. To use the data that we have, then multiply the seasonal index. Alright, so this is like an opposite operation from it. So divide means remove the seasonal effect, so deseasonalize data. So when you want to factor in, so we multiply it. Alright, so that's the idea. Okay, so now let's try to look at this. Yeah, just a very quick one before we move on. Yeah, so in a previous lesson, I also talked about this as well. So the data that we are going to use it to do further prediction is the data that after we factor out the seasonal effect. So which means that remember that no matter you are using moving average data or you are using the seasonalized data, we are not going to use raw data to do any further to do the prediction. So we are going to use the data that after we remove the seasonal effect. So because by using the data that after we do smoothing, right, is able to give us a much more clearer trend without any seasonal effect. So from that, it will give us a better prediction of what a deseasonalized data is. So at this part, after we find out this, then which means that we are going to do linear regression. So we are going to fit in the linear regression so that we can see the underlying trend no matter from the gradient or from the shape of the scatter plot and so on. Okay, so then at this part, so when we try to do prediction, the first step that we are going to do is exactly the same with bivariate data, no matter we are using moving average or deseasonalization. So first thing is going to substitute the t that we are going to find. So after we have do substitution, then we are getting like, for example, y equals mx plus c. After you substitute the x, then you'll be able to get the y, right? So from that, you are able to get a predicted moving average or predicted deseasonalized data. Predicted, I'm using a short form here, predicted MA or predicted deseasonalized data. So second step that we need to do is to factor in the seasonal effect. So which means multiply the seasonal index. So what are we going to do here is to factor in seasonal effect. Alright, so that's the idea. Now we'll be using the previous example that we have been using like so far in the lesson so that you try to understand how to do this step. Then I'm going to use the last example to explain the whole thing again so you can understand like what's the idea or put when we try to put everything like in one question, then you'll be able to understand the whole process and why do you need to do that and how do you do that. Alright, so let's look at example 1. Alright, so I'm not going to repeat the question again. So basically, this is our latest progress for this question, which we have find out what's the seasonal index for each of the period here. Then after that, we also have carry out deseasonalization, which is to divide all the raw data by using its respective seasonal index that we have. Okay, so we are going to start from here, which we are going to feed the linear regression to the data first. Alright, so let's use your calculator. So the thing that we need to do here is to key in our value. So again, remember calculator doesn't recognize the period of time like during the first 4 months, second 4 months. So what we are going to do is just to assign a value of it. So which means this will be like data number 1, 2, 3, 4, 5, 6, and so on. Alright, so that will be the number that we try to fit in. Alright, so let's try to use some time to key in that. So I'm going to fast forward this. So make sure that you have assigning your variable. Alright, so make sure that after you have keyed in all the values, just go through very quickly to check whether everything is correct or not. then make sure that you're having like 10 row, which means 10 datas here. So yeah, make sure everything is correct before you move on. Alright, so before you do the regression model, make sure that you have assigned the variable here. In my case here, I put down time and visitor, but of course, if you want to use other alphabet, that's totally fine. Alright, so same thing, how do we carry out the linear regression? Menu, statistic, stat calculation, then linear regression. Alright, so if you are using numbering, then it will be menu 413. Alright, so at x list, so this is our explanatory variable. So our explanatory variable will always be the time. Alright, so we are using the time to explain the change in our variable here, which is the number of visitor. Alright, so in this case, you want to use it in C also can, D also can, because we are not doing any residual plot normally. So you can just put C, or if you want to make it a habit, just leave it at D. Alright, so in this case, then you can see mx plus c. So this will be our linear regression model. So in this case, we'll try to put 4 decimal places. Yeah, but I mean in the real life situation, then you'll be looking at the requirement of the question. Then it will give you an idea of how many decimal places that you are putting it. But if let's say it's not given, normally I'll say for a linear regression model, it's good to have 3 or more. Okay. Alright, so in this case, the question didn't give us any short form, right? Then let's just do this. So we are going to use time. Okay, then visitor, we are going to use V. Alright, so which means our regression equation will be equals to V is equal to gradient. So Y equals to mx plus c. So M is 2.5178. So 2.5178. So x is t in this case, and our c here, the y-intercept is 30.8425. So you can look at this and to know that whether what's the value after that. So it's 6, so that's why it's 8425 lah. So 30 plus, okay, if it's negative, then it's going to be minus. So it's positive, then it's plus. So 30.8425. Alright, it's just as simple as that. Okay, so what are we going to use this to do in the next part is to do the prediction. So question 1 is to predict the number of the visitor during the third 4 months of 2014 and also the third 4 month for, the second 4 month for 2017. Alright, so let's try to solve the first one first. So you can try to look at this. So this value represent 1, 2, 3, 4. So you can try to look at like the last number to know what's the value that you're supposed to substitute. So you can try to look at it like this. So for 2011, it's going to be data 1 to 3. So for 2012, it's going to be 4 to 6. So you know that until 2013, it's going to be 3, 6. This is until 9, right? Then after that, we are finding out the third 4 months for 2014. So which means in this case, it will be like the next one, which is 10, 11. So that's going to be 12. Okay, I think that makes sense, right? Yeah, it's not hard. So basically, you are just following the sequence, then you find out what is the number of the data point that representing the respective period of time. So in this case, because you know 2013 during third 4 months is 9. So which means 2014, first 4 month will be 10 lah, then second 4 month 11, so third 4 month is 12. So which means that to find out for third 4 months of 2014, okay, alright, then we are going to substitute 12 into our value. So which means V will be equal to 2.5178. Alright, so our T is 12. So plus 30.8425. Alright, so you're just going to use your calculator to do this. So multiply 12 plus 30.8425 and you should be able to get the answer of 61.0561. Alright, so remember this is a value that you get after you factor out the seasonal effect. So which means that this is the value that this is a prediction on the deseasonalized visitor. So which means that if you are going to put this value, right, you will be putting them under this column rather than this column, right? So which means to make this prediction go back in keeping with the raw data, what do we need to do is to factor in the seasonal effect. Because we know that, for example, third 4 months, you can see that the seasonal index is 0.9670. So which means the performance during the third 4 months is generally slightly lower than the average that you have. So this is like the average that you have. So you need to multiply the seasonal index so that you get back the you get a much more meaningful prediction. Alright, so in this case, you can see that you are predicting for the third 4 months. So which means that we are going to use the seasonal index for the third 4 months. So just multiply the seasonal index. So 61.0561. Alright, so multiply by the number here, 0.9670. Alright, so just by using calculator, then you'll be able to get an answer. So remember, in this case, we are talking about 1,000. So which means that if we are rounding it off, then only like into 3 lah. The maximum that we can put in is 3, because you cannot say like 0.5%, right? So that's why 59.014. So in this case, it's 1,000. So you can just round it off. Alright, so the visitor that we are predicting, it will be 59,041. Alright, if you don't want to write like this, which means at the end here, you should be writing down 1,000 lah. Alright, so which means like this. Okay, and yeah, this is actually good enough. So to sync to what we have in the table. Alright, so that would be the answer for the prediction. Alright, so which means it's basically the same thing, but you just do one more extra step, which is to multiplying the corresponding seasonal index. Let's try one more. Okay, state is reliability. So you can see that normally for all time series data that we are doing, right, the location of the prediction is most likely to be extrapolation. But the idea is that what we are trying to do here is to try to find out a much more analyzed, much more accurate prediction by using deseasonalization or by smoothing out the data than by factor in the seasonal effect again, so to get a much more educated guess here. So you can imagine that since all the data that we are dealing is to forecast what is going to happen in the future, so which means if you are trying to predict like a near future, so which means it will be like a close extrapolation, then we can say that it's actually reliable. But if let's say you are predicting for a value that's like in the far future, then we doesn't know whether this linear regression model is going to still represent that time well or not. So which means in that case, then it will be not reliable. So which means in this thing, is still considered reliable. Alright, because like it's still within like one cycle after that. Because the data that you have is actually up to 2014 during the first 4 months, right? And you are predicting the third 4 month. So basically they are pretty, the range of the data isn't that far away. So which means it's reliable. So because it's a close extrapolation, the data that you are predicting is basically within one cycle, within one future cycle that you have. Alright, so let's try to look at the second one. So we need to predict the value for the second 4 months for 2017. Okay, so yeah, let me try to write it here. So you know that for data 1 to 3 is supposed to be for 2011. So data 4 to 6, it will be for 2012. Until 9, 2013. Until 12, 2014. So which means until 15, it will be 2015. So until 18, then it will be 2016. Then until data 21, then it will be 2017. So you can imagine during the third 4 months, it will be 21. So which means during the second 4 months, then it will be 20. So we need to substitute 20 in the linear regression. So for second 4 months, for 2017, right? So we are going to substitute 20. Same thing, just by using our calculator. So let's try to find out the value. So 30 plus. All right, then you'll be able to get 81.1985. So similarly, we need to factor in the seasonal index for this period. So for second 4 months, so you can see the seasonal index is 0.7946. So we are going to multiply it. So 81.1985, okay, multiply 0.7946. Alright, so after you multiply it, same thing, just round it off to 3 decimal places. So it's a logical answer based on the question. Alright, so 64.520 thousands. Alright, so you can see that after you have multiplied it, it becomes a lower number. Why is this so? Because the overall performance for second 4 months, by looking at the seasonal index, you know that the performance is normally lower than the average. So which means that after you multiplying, then you can get a lower number, which means that's correct because you have factored in the seasonal effect. Alright, so it might be a little bit difficult to look at this case. Later in the second example, I'm going to use graph, then from there, hopefully you can understand it better, the idea. If let's say until now you can't imagine actually why do you need to multiply it back again. Okay, so in this case, the answer will be not reliable because the data that we are dealing with, you can see that the last data that we have is 2014, but we are predicting for 2017, which is like quite far away. So this answer will be like far, so not reliable. So you can see that it's like extrapolation, or you can see it's like an extreme extrapolation. It's actually not too extreme, but yeah, I think we can just put extrapolation. All right, yeah, so that's the idea. All right, so let's move on to the last example, and we try to make a very yeah, that's like a closing for this topic. In this example, I also want to show you like how a complete table look like if let's say you are given like a set of raw data that we need to do the whole thing from raw data to find the trend and to deseasonalize the data to fit in the linear regression until we get the prediction. Alright, so this will be normally how the table looks like in your exams as well. So the second thing is I'm going to use this example because when we talk about temperature, we talk about like 4 seasons. So it will be easier for you to understand the idea for seasonal effect. Then I'm going to use the graph here to, explain the whole thing again. Alright, so just a revision for you. Yeah, I think you should be quite familiar with this already, I hope. Yeah, so because this is just basically how to find out your seasonal index and how to do deseasonalization, but it's just that we are putting everything in one question. Alright, so this is a table that shows the temperature of a city over 3 years. So 2018, 19, 2020. So 2021, we only have one value lah. Okay, so the first thing that you need to do to find out the seasonal index first. Alright, so let's try to find out the mean here. So 18.4 plus, then divide by 4. Alright, so you should be able to remember this. So if you still need, then I'll just write down for the first one. Okay, plus 23.8 plus 12.3 plus 1.1. Alright, divide by 4. So you'll be able to get the quarterly mean is 13.9. So this is like the average for the year for 2018. So the same thing, we find out the average for 2019 and that will be equal to 15.375. So average for 2020 is going to give us 17.15. Alright, so if let's say you want to try out yourself, right, feel free to just pause the video there and find out all the value here. Then after that, just check the answer. That's totally fine for me. So in the last one, we only have one, so that's why we are not going to use this when we try to identify the seasonal index. We are just going to use it when we try to include that to for the deseasonalized data. But for identifying the seasonal index, we are not going to use this value. Alright, so the next thing that we need to do is to find out the respective percentage. So 18.4 divide by 13.9. Alright, multiply 100%. Okay, so you'll be able to get 132.37. Alright, so I'm not putting a lot of space here because in your exams, there's going to be numbers also. You are not given like the working, right? So that's why I want you to be able to know what do you need to do if let's say you have the row of percentage and so on. So in this case, the same thing, you can try to pause the video. I'm going to fast forward this. Basically, you are just using the raw data to divide by the respective quarterly mean. Alright, so after you find out all this value, right? So remember how to check it. So it's to plus all these value together. So you have 1, 2, 3, 4. So when you plus them together, it should give you a number that is very near to 400. Or it's like exact 400, or if let's say there's some difference there. That's basically because of the rounding. But the maximum difference that you are having is just like 0.01 or 0.02, something like that lah. Alright, so please remember to check that. So the average of all these values should be equals to 100%. So which means when you plus them all together, it should equals to 400 because you have 4 data, you have 4 period in one cycle. So after we have find out this, then now we can try to identify the seasonal index, right, by using the percentage of the quarterly mean here. So what we are trying to do is to look at the different quarter, the different period. So which means this is the percentage by March. This is the March 2018. So March 2019, March 2020. So we are going to find out the average, so we can find out what's the average performance during the period of March for each of the year. So you can see that normally for March, right, the average temperature is slightly higher than the quarterly mean that you have. Alright, so in this case, so same thing, 1, 2, 3. So plus them together, then divide by 3. So you should be able to get seasonal index here. So in this case, we are writing it in decimal. So which means that after you find out the value, then you divide by 100% as well. So which means you'll be able to get 1.2711. Alright, let me repeat again. This number plus this number plus this number, and you divide by 3. So after you get the answer, then just convert it to seasonal, just convert it to decimal lah, basically. The answer that you get is 127.11. So after you convert to decimal, you get 1.2711. Alright, then the next thing to find out for June. So you can see that when you look at the percentage here, yeah, for June is normally higher than the quarterly mean as well. So the average temperature for the quarter of June is normally higher than the quarterly mean. So same thing, we find out the average for the percentage for June, then you will be able to get the seasonal index for June. So this value, maybe I use different color, then it's easier. Alright, so this just now, right, this 3 value divide by 3, then you get for the quarter of March. So when you continue, so this is the second one, right? 1, 2, 3. Okay, plus them together, then divide by 3. Same thing, convert it to decimal, then you'll be able to get 1.6853. Alright, so that's seasonal index for June. Let me try to change this. Okay, next one for September, same thing. So we have here. So you can see that for September, the quarter of September, by looking at the percentage, is normally like 11 or 12% lower than the quarterly mean, that the average temperature that you have lah. Okay, So in this case, then which means that we are going to use this number, and this number, divide by 3, and you'll be plus them, divide by 3, and you'll be able to get 0.8766. All right, and last but not least, for the quarter for December, so yeah, you can see that the number here is even like much more lesser. So yeah, it's like 1.1, 2.9, 4.0. So when you try to change it to percentage, you can see 7.9, 18.8, 23.3. So normally it's like much more lower than the quarterly mean that you have. So this value, this value, this value. Okay, so plus them, then divide by 3, you'll be able to get the average, then that's going to be the seasonal index for the quarter of December, which is 0.1670. So similarly, after you find out the seasonal index, when you plus them together, it should be able to give you 4 as well. So again, no worries about the part where whether you should put them into percentage or whether you should put them in decimal, because in your real exam, they wouldn't ask you to do everything by yourself. So it's the same thing like moving average. They will just give like A, B, C, D, then you will just need to find out the A, B, C, D, or like seasonal index, maybe you have one empty, then if let's say, okay, remember this here. So if let's say you have, for example, you are given this 3 value and this is the empty one. So yeah, first thing, maybe you can use the data, but the easier way to do that is that you know that this 4 value, when you plus them together, it should give you 4 in decimal or 400 in percentage, right? So I'm just going to use 4 to minus this, and you should be able to get the number here. So it doesn't really need to go through like the difficult, the whole process of how we find it just now. So in the exams itself, you can use the idea where you understand that the sum of all these values should be equals to 4, then you just minus off, then you get this value. So that works as well. All right, so that's the idea. Okay, so now we move on. So after we find out the seasonal index, then we need to do the seasonalization, right? So find out all this value. So remember, when you are trying to do the seasonalizing, so what you are doing is using the average temperature to divide by the seasonal index, because we are factor out the seasonal index. So 18.4 divided by 1.2711, 23.8 divided by 1.6853, 12.3 divided by 0.8766, 1.1 divided by 0.1670. Alright, so the same thing going on lah. So first one, second one, third one, fourth one, and so on. So alternatively, in this case, you can try to use your calculator to do that as well, because later we are going to find out the regression equation also, right? But then same thing. So don't rely on the calculator in a part where you key in the whole thing now, you still remember. I mean, you need to know how to do it manually as well, right? So for example, in the exams, you are just going to find out one value. You doesn't really want to key in all the value, because some of the cases maybe the calculator will give you, sorry, the question will straight away give you the regression equation that you actually doesn't really need to key in all the data to find that out. So in that case, you doesn't really want to waste your time to key in all the value just for sake to find out like one value here. Then you'll be using your scientific calculator. But then if let's say you have the whole set of data that you need to find, then you can normally use your graphing calculator lah. Alright, so I hope that you still remember how to do this. So if you don't want to open a new page, just going to use here. So yeah, for my easy case, I'm just going to open another new document. Alright, so add list and spreadsheet as well. So key in the raw data that we have. So yeah, I'm going to fast forward the process as well, so you can try to look at it. Then yeah, you can try to just follow. Alright, so same thing, every time, remember to check. Alright, so now key in the seasonal index that we have. Right, so the first one is for March. Alright, second. Okay, then third. Fourth. Alright, so after you have keyed in all the value here, then what we are going to do is just like copy paste. So make sure you are here. Alright, then you just shift, go down, shift, go down, shift, go down, then control, then press C. So that's copy. So go down to this cell, then after that control V. So you paste it, then it's the same thing, control V again. So make sure that's correct. Then the last one, you can just type it in, or you want to copy again, you can also. So here, then control, yeah, because you know that's going to be much, right? So control copy, then control V. All right, so you got all this value, then how do you deseasonalize it is to divide them. So equal to the cell for B1, you will divide by C1. All right, then same thing, then B2 divide by C2. So after you find out 1, 2, then you use your scientific calculator to check if that's correct, then you can move on lah. So which means you're just going to shift. All right, if you want to use 2 also can, then menu, data, fill. Okay, then you just go down, go down, go down, go down until you get then enter. Alright, then you got all your value here. So I'm just going to put in all this value in the table and fast forward the process. Alright, so remember to check all these value are correct. So now let's try to continue in our calculator to find out the linear regression model. So make sure you try to assign to the correct variable. So this will be our time. Alright, so this is our raw data, the temperature. So this is the seasonal index that we are using. So make sure that you are not confusing with it. Then the last one is the data that we get after we deseasonalize the data. So I'm just going to put DS lah. Alright, so remember when you are trying to do, when you are creating the linear regression model, it should be using the time and also the deseasonalized data, not the raw data. So menu, so statistic, stat calculation, linear regression. So time, Y list, deseasonalization data. So A, B, C, D, E, F. Alright, so I'm just going to put in here so you can see this will be our gradient, then this will be our B. So something that you can try to check it out is by looking at the data, by looking at the quarterly mean, right? You can see the increment isn't that big. So you are getting a gradient of 0 point something, that's correct. If you are getting a very big number, then you know something must, yeah, there's something wrong there lah. So make sure that you try to check it. So in this case, since it's 0 point something, we are going to use 4 significant figure also. So let's try to write it out. So in this case, we are going to use big T for temperature. Then yeah, this will be our small t, the time. Then this is our big T, the temperature. So yeah, no worries. In exams, you don't need to create by yourself. Normally, it will be given. If not, then you need to write the whole thing like temperature equals to blah, blah, time plus this one. Okay, so 0.96277 multiply the time plus 11.3217. Alright, so now we have obtained the regression equation. Then we are just going to use it to break the average temperature in June 2022. So yeah, this is March. So you can see until data 4, data 8, data 12. So for 2000, until the end for 2021, it will be 16. So 2022, it will be 20. So which mean in this case, it will be from 17 lah. 17, 18, 19, 20. Alright, so 20 is supposed to be for December, right? Then 19 is for September. So that's why 18, it will be for June lah. So which means in this case, we need to substitute T equals to 18. Alright, so T equal to 0 0.6277 18 plus 11.3217. Alright, so 0 0.277 times 18, 11.3217. So you'll be able to get 22.6203. So remember, last thing, factor in the seasonal index. So this is for June. So the normally for June, the average temperature is higher than the normal. So just putting it there. Right, then write down your last answer here. Then you will be able to get 38.12. Alright, so that's the answer. So in this case, they give you degrees Celsius, so that's why same thing, degrees Celsius. Alright, so that's the whole idea here. So this process is going to be exactly the same if you are doing moving average. It's just that the data that you have for this column is the data that you get after you carry out moving average lah. So of course the answer that you'll get out for your regression model will be different. So that's why your T will be different. Then after that you also need to factor in the seasonal index, but at the end the answer will be different as well. But no worries about that because that's like the they are valid approach. So it's just that you are using different thing only. So the normally the question will tell you what to do lor. I mean they don't like straight away throw you the whole question, then you need to identify yourself in your real exams. Alright, so that's basically the idea. So at the last part, I'm just going to use this graph, and by looking at our graphing calculator to explain the whole idea again. So I hope that you can understand by using this approach for temperature. Alright, so this is the last part for the notes. Okay, so you doesn't really need to draw. I hope that you can listen and try to understand. If you want to write down the notes after that, then it's on yourself. Alright, okay, so the idea of why are we doing this whole bunch of thing instead of like why not just try to find out the regression model by using this, then after that straight away substitute. So the idea is that you can see that the data that we are dealing with isn't the same like bivariate data. So it's not something that is something that looks like this, then you can definitely see that it's going to be like a straight line. So in this case, all this fluctuation is basically caused by the season. It's not something that caused by the data itself. I mean, you can see that you cannot say that the temperature is decreases by looking at 18.4 to 1.1 because that's basically caused by the season from the spring until the winter. It's not basically caused by the temperature on this earth is basically decreasing. That's caused by season. So what do we need to do? And also the other hand, right, you can try to imagine when we try to do prediction, it's also quite impossible that at the end that it's going to be increase, then decrease. But how am I going to know how much I should increase? Then how do I know how much I should decrease and so on? You get what I mean, right? So that's why at the end we still need to be able to fit them into like the regression model to do that. So the first thing that we need to do is we need to factor out all the effect that caused by the season first, because we want to see what actually happened to the overall trend for the temperature when we try to observe it in a long run. So that's why we need to remove the effect that caused by, because it is summer, so normally it's higher. Because it is winter, so that's why that's normally lower. We want to remove all this effect that caused by the season. So that's the idea why do we do deseasonalization. So after we have find this out and we have divide, right? So you will get a number that is like much more closer to each other. So this is like the value that you can see that it's like decrease, then maybe it's like increase. So this is caused by the real trend of the temperature, but it's not caused by the season anymore. So that's the idea of it. Okay, so let's look at the graphing calculator. So you can see that what happened after you try to carry out deseasonalization is that, so the data, this is the original data that we have, right, which is the data that you see in our previous picture. So this is a seasonal data. So let me try to add in another. Okay, so this is the data that after we do deseasonalization. So you can see that this thing, although it's not like 100% of a straight line, but when you try to compare to the previous one, then you can see that it's it is more like a straight line when you try to compare to the previous one. So this is the one that we get after we remove the seasonal effect. then we want to check out what is the trend after we try to look at it in a long run. So if I am trying to add in the regression line for this, then you'll be able to see this. So which means that you see this is the equation that we get just now, right? So this is the straight line that we are drawing. Okay, so now let's try to imagine. If I get this value, it's going to be something like this. So you can see it's an increasing trend, right? By looking at the gradient here, you know that it's a positive number as well. So which means for every one season, the increment is actually 0.6. But then how come you cannot see it from this average temperature? Because you have season. So for example, when you go from autumn to winter, right, although there is increment in the overall trend, but you cannot see it because now it's a transition from autumn to winter. Then supposingly, no matter how your temperature increase, you will still get a lower temperature because of that is winter. You get what I mean, right? So that's the idea. So you can imagine that what are we doing here is to find the linear regression, then to substitute the value. So after you substitute, right, the value that you are getting is basically on this line as well, right? Okay, so why is this value we are not straight why we are not straight away using this value, but we need to multiply the value again? Because you can imagine that if let's say I am predicting something that is here, all right, then you know that this is going to be summer, am I right? It's just that following the average temperature, this is the average temperature that I get. But I know that normally for summer, it will be 68% more than the normal average temperature that you have. So this is supposed to be a higher up compared to this one. So how do you get this value from this value is to multiply the seasonal index. So you factor in the seasonal index again, so you get this. So I hope that you get the idea. So from the raw data, you deseasonalize it so to get a much more nearer data. From the from the less fluctuated data, then we fit into the linear regression. So we use the linear regression to see the overall trend, whether it's increasing or decreasing by looking at the gradient or by looking at the regression line. Then you'll be able to see the increment or the decrement. So if let's say we are talking about temperature, then we can talk about by fitting in the regression model, then you can see that despite of the season, actually the temperature in this earth is increasing 0.6 for every quarter here. So that's the idea. So after you have find this out, then you know that because the thing that you are finding out is basically prediction on the deseasonalized data that doesn't represent well for the actual data. So for example, if you want to do this, then you need to factor in the seasonal index. So that's why you need to multiply a seasonal index so you get a number that is much more aligned to the normal performance for each of the season. All right, so that's the idea. So I hope that you can understand this whole thing so that you do not really need to memorize, but you understand why are you doing this. All right, so that's basically the end for this chapter. So yeah, if let's say you got any question, please let me know. So please use the break time to do your revision. So I'll see you during the mock exam for next week. Make sure you're going through the exams briefing and everything that you need to know and everything that you need to do, everything that you need to prepare beforehand. All right, so that's for this topic. All right, thank you.